We're surrounded. Look at them all. There's schools of fish, crashes of rhinos, gaggles of geese. They're everywhere. They're all populations.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by new improved Populax. For those times when you feel overpopulated.
We're not alone. No, we're all part of some population.
Please exit in an orderly fashion.
These people would be part of the human population.
Next night at 2 and 15 minutes.
Now, all living things are part of a population. Now, there's populations of plants, populations of insects. There's even huge populations of things that are smaller than you can see with just your eye. Populations compete with each other, but they also depend on each other for food and places to live. Populations are all over the planet. Take a look at this. It's our planetary population bin of science. So this big bin is like the planet Earth. And we have different populations living in it, different populations of balls. So we got red balls, orange balls, yellow balls, green balls, and blue balls. And they're all in the Earth, competing with each other. See, maybe they're competing for space and food, the same way trees compete for sunlight and nutrients in the soil, and birds compete for insects, and insects compete for nectar and pollen from flowers. Now, suppose we added one more ball, one more yellow ball, one individual from the yellow ball population. Well, when we add it, we might force a few of the existing balls out of the bin. You may not buy it with one ball, but suppose we added a whole bunch of balls, a whole population of balls. You ready? 3, 2, 1! Oh, I forgot. That's the safety. This is the real one. Here, okay. 3, 2, 1! What? See? As we add more yellow balls, it forces some of the other balls out of the bin. See?
No.
So if you have too many of one species living on a planet, you're going to force some of the other balls out. See?
No.
I'm okay.
We weren't worried about that, actually.
A group of organisms of the same species, living in a particular place at the same time, forms a population.
A kindle of kittens, a litter of puppies, a string of ponies, a herd of bison, a rabble of butterflies, a rafter of turkeys, a bunch of dogs. I'm kidding. A colony of ants, a swarm of bees, a peep of chickens, a pride of lions, a leap of leopards, a murder of crows, a smack of jellyfish, a gaggle of geese, a pod of whales, a bale of turtles, a basque of crocodiles, a crowd of people, a race of humans. We're all populations. Don't forget, a trip of ghosts. Well,
Take the hypotenuse divided by the subtrahend x times y to the third. Don't take the value. Maybe if I divide the log value of x and subdivide it into
Now pretend like you're surprised to see us.
Oh, hi.
Hi.
I've been working really late on this one.
Have you?
You know how populations can grow really fast, right?
Right.
Well, say you have a population of just 2 weeds.
You have a population
Like
of
these.
Yeah.
And every time a weed makes a seed, that seed turns into a whole new weed.
Okay.
So the population doubles every time.
Sure.
You can see for yourself using a calculator.
All right.
First, put in 2 times 2.
Okay.
Keep track of how many 2s you put in
I will.
on this piece of paper. Then again by 2.
Why don't you quit telling me what to do?
Times 2. Times 2. 2. Whoa! Wow! Look how big the numbers got in just 10 weeks. It's over 1,000. Try 16 weeks. It's over 60,000. So if the weeds could grow all summer, the world would be nothing but weeds. But the reason the weed population doesn't get that big is because there's other weeds and plants competing for the same space. Populations usually keep each other under control. And I got more work to do.
there are more humans in the world today than there were yesterday. And there will be more tomorrow than there are today. Please consider the following. The human population is growing very fast. And I'd like to show you a famous way of looking at it. We're going to generate a penny population of science. Take a look at this. We'll start with 1 penny. Then for every penny that's here, we'll double it. So that's 2 pennies. Then 4, 8, then 16 pennies. And if we double 16, we get 32. Double that, 64. Then 128. If we double that, we get 256. Then 512. Then 1,024. And that's in 10 doublings. But if we double it 10 more times, we get a big number. 1,048,576. And if we keep going, the number gets huge. Almost unimaginably huge. The pennies just keep adding up. More and more. So eventually, we've got billions of them. Just like we have billions of people living on the planet Earth. Now, when I was in 4th grade, there were about 3 billion people on Earth. Now, there's almost 6 billion. And by the time people who are in 4th grade now are my age, there could be 12 or 15 billion. You see how fast populations can increase? Well, thank you for joining me on...
Just how fast do colonies of bacteria grow? Some have doubling times of 20 minutes.
That is, every 20 minutes, the number of cells in a culture doubles.
You know, living around all the food we eat are populations of tiny organisms called bacteria. Now, bacteria are smaller than you can see with just your eye, but they're there. Like when you eat frozen yogurt like this. There are bacteria that get inside your stomach. In fact, there are more bacteria living in your stomach than there are people living on Earth. See, bacteria live everywhere. They live around our food, on our skin, and in our stomachs. Isn't that wild? You want some?
Not really, no, I don't.
A population is a group of living things of the same kind in an area. See those kids behind me? They're part of a population. And you and your family, you're part of a population too.
Dad, is it true that we're a population?
Well, that's a good question, Richie. Actually, I think your mother would be happy to answer that for you, Richie.
Mom, is it true that we're a population?
Yes, Richie. We are close-dwelling individuals of the species Homo sapiens sapiens. Taken together, we constitute a small percentage of the human gene pool, a collection of similar genetic material which can successfully be combined as well as rearranged, which ensures our survival as a population, as well as a family.
The success or failure of any one species is dependent on its rate of reproduction, its available food supply, and the number of its natural enemies.
Cheetahs are one of 2 large cats that can purr. My name is Susan Millard, and I work for the Zoological Society of San Diego. We want to learn about the best ways to feed them, the best ways to house them, how to put them together so that we can get reproduction from these animals. The reason this is important is because we don't know what's going to happen to the wild population. Cheetahs used to inhabit all of Africa and parts of Asia as well. Starting probably in the early 1900s, the cheetah population started declining because of the human population and the loss of habitat for these animals. So if we don't understand how to work with these animals and how to take care of them, then we're not going to be able to help the animals in the wild as well. That's an improvement. It's 29 miles an hour. Wild populations have been estimated to run at between 60 and 70 miles per hour, which is extremely fast. So this is a way of getting them to exercise and to run. It's a voluntary thing for them, and we hope it's going to make them in better shape. It's not only the cheetah population that's at risk, there's a lot of species of animals that are at risk. And as a scientist, what we want to do is we want to learn more about these animals so that we can help those populations in the future.
populations don't always stay the same. Sometimes they go up and down like a seesaw. Like, let's say you have a population of wolves and a population of deer. Well, the deer population will get as big as it can by eating the food that's available, maybe tender shoots in the forest. Well, the wolves eat the deer. So, at first, the more deer there are, the more wolves there'll be. But then as the wolves get as the wolf population gets bigger and bigger, they'll be eating deer, and eventually there won't be enough deer to keep the wolf population that big. So the wolf population will start to get smaller, will go down. Then the deer population will get larger again because there aren't as many wolves around to eat them. So the populations are constantly going up and down. Not only do they compete with each other for food and places to live, but they depend on each other. This peaceful field of tulips is really a population battlefield. Populations of tulips, or any other crop, are always competing with other populations, like populations of weeds, or viruses, aphids, or nematodes, it's little worms. They're all competing for the same space and for food. Farmers help one population, the tulips, compete against all the other ones. Like, they spray to prevent weeds from growing. They even introduce special microorganisms that help prevent the unwanted microorganisms from doing very well. So we end up with mainly one population. Tulips! Ha! They beautiful? Just makes me want to tiptoe through them. Yeah! Yeah! This tree is a member of a population. But look, this vine is a member of a population too, and it's sucking nutrients right out of the tree. If the tree weren't here, the vine wouldn't be here. And the vine is a member of a type of population we call a parasite, a living thing that lives right off of other living things. And you're probably familiar with other types of parasites, like mosquitoes. You all right? You okay?
The study of plant and animal populations helps us to make decisions about the future of our human population, so that we may maintain our own balance with nature.
Here we are opening up a colony of carpenter ants.
They build their nests in trees, stumps, or other timbers. A colony's nest may cover many square yards and have hundreds of entrances.
Populations compete for food and places to live. Whoa.
Each of these is a honeybee hive, and each one is its own population. Each bee knows where they have to go so they're in the right population.
You have to control the population so it doesn't get overpopulated inside. You keep on adding more supers so they have enough room to grow. A super is like part of that building, like an addition, and you have your honeycomb in it so they can hatch bees and can store their nectar.
I found the queen bee here. She's the leader of this colony. There's only one queen out of 43,000 bees. There are different jobs for the bees, and there's different duties that each bee serves. And this is a drone bee right here. The drone's prime purpose is to mate with the queen when she first hatches from her egg. The smaller ones are the females. They're the worker bees. These guys are called guard bees. And they check every single bee that enters and leaves the hive for a special scent, which they call a pheromone. The guy they're attacking, who is right there with his tongue sticking out, he's from a different hive, and they're all attacking him, trying to sting him. These bees are part of the population of this hive. They are busily working on eating honey and making it so it's at the right moisture content. They eat it, and then they put it in their honey stomachs, and then they regurgitate it back into the cell. So it's the right moisture content. The honey you eat is actually bee barf. Bee barf, it's the best.
Hey, Margaret. How you doing?
Hi, Bill. Are you having fun?
Oh, yeah. Just, watching these populations compete for food. It's wild. Look at those humans.
I know. It's amazing what people will do for food. They just compete with each other, don't they? They'll just do anything.
Yeah, the human population is getting so big, it's actually competing with itself for food. It's just fascinating. How one population will move fighting for the same resources.
Isn't that Wild Wagner?
Oh, I didn't see him.
Hey, look over there. It's Goofy.
Good guy. I didn't see him.
Look over there. 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 Look over there.
Well, what happened to the grapes?
The human population is growing very fast. It's forcing other populations to move. A population of frogs once lived here. Now it's just a street and a bunch of stores. I don't see any frogs around here. Do you? Do you? Do you?
Stop!
As the human population continues to grow, we're taking up more and more space, the space of other populations. We're destroying their habitats, where they live. Without a place to live, the members of these populations are in danger of becoming extinct. And we call these endangered species. You probably know some endangered species, like elephants, rhinoceroses, the California condor, and certain species of fish called salmon. They're all in danger of being wiped out because the human population is crowding them out. It's getting so big. We're competing with them by accident. In order to keep this from happening, we have to respect other populations. They live here too, you know. You know?
Yeah.
How do they do that?
Hey, over here! Over here!
Hey! Yeah. Populations compete for places to live, things to eat, but it's getting harder and harder to compete with the human population because the human population is growing so fast. Every year, there's 93 million new people in the world. I mean, that's a lot of people. That's more than the country of Mexico being added to the world every year. I mean, just think about that. It's a lot of people taking up space and competing. I mean, we're a population. The amounts of resources, the amounts of energy used by humans is huge. In fact, the United States uses more energy than all the other populations of the world combined. I mean, that's a lot of energy. I mean, just think about it. So, all populations are going to be limited by the resources, what they can find to eat, and the space they have to live. We have to find a way to restrict the rate of growth of the human population, or it's going to get out of hand. There won't be enough for everybody to eat. Things are going to get hard for everyone. Where's everybody going?
Watching groups of living things, trying to find the reasoning. Get the scope and watch some more. Populations I have seen are made of groups of living things. And if you're keeping score, they compete for food, they compete for homes. Populations all compete, as everybody knows. Populations, there are different populations competing to survive. Populations, and watching populations, we learn about life. The human race is growing fast, other populations might not last. Some species are gone forever. Now we've got to watch what we do, let other species live here too. We can all be here together. We compete for food, we compete for homes. Populations all compete, as everybody knows. Populations, there are different populations competing to survive. Populations, and watching populations, we learn about life.
Well, that's our show. Thanks for watching. If you'll excuse me, I'm going to try to improve the accuracy on some of our energy flow model coefficients. See ya!
Produced in association with the National Science Foundation.
Follow me, come on down. I got to stay on camera 30 seconds.
A litter of puppies, a nest of rabbits. A litter of puppies, a nest of rabbits, a bale of turtles, a trip of goats, a rag of colts, a string of ponies, a kindle of kittens. A leap of leopards, a rabble of butterflies, and I start from the beginning of that paragraph. A business of ferrets, a murder of crows, a crash of rhinoceroses, a rafter of turkeys, a cartload of chimps,